Some of you made attempts of that extra question that I gave you the last time. That was quite commendable. But some of you introduced something, and that wasn't just okay for me. So what is that thing that you introduced? So I'm going to go to this one. I ask you to do square root of 2 plus root 3 minus square root of 2 minus root 3 in the exact form without calculator. And I saw something like square root of, I don't know, maybe 4 plus square root of 3 divided by something like that. Somebody did something like this. And I wonder, how did you get this? No one can tell me by just thinking about it in my head. I know that the square root of this number is this number. So some calculator, whatever, has been included. So that's not what I asked you to do. I put int and I sent it back to those that actually did it. So I'm going to share that with the class also. So the idea is to let the first one be some letter A, and let the second one be some letter B. Which means the entire question you are trying to do is what, everybody? So the question itself, if I let this be A and this be B, the question you are trying to do, this one, is actually what?
A minus B.
A minus B. So what you are now trying to get is A minus B. So how do you get A minus B is the next step. So that's why I said in the clue that I sent to you, I said consider A minus B squared. If we can work out A minus B squared, then we can find the square root of that, and that gives us our A minus B. Now, A minus B squared is A squared minus 2AB plus B squared, isn't it? Right? So if you substitute A minus B squared is what? A squared, that's this one, which is the first one squared, right? Square root of 2 plus root 3 squared minus 2AB minus 2 square root of, this is A, times square root of, this is B, then plus B squared, square root of 2 minus root 3 squared. And using what you know about surd, when you square a surd, Justin, what happens?
The square root gets removed.
The square root gets removed, so you have this. Or when you multiply two surds, what happens? Quickly, when I ask you a question, 30 seconds, please. I can't hear you. You need to mute yourself.
Multiply the things at the square root.
Say that again.
You multiply the things in the square root.
Yes, so you can multiply the number under the same square root, right? So you can use the same square roots. You multiply them under one single square root. That is the property of surd. We learned that last time. And this is the one Justin answered again. So from here, our problem is reducing because this and this can disappear. So A minus B becomes 2 minus 2 roots. In this square root, what do you notice? What does this look like?
Difference of squares.
Difference of two squares. Thank you. So difference of 2 squared, that is m plus n, m minus n. That will be m squared minus n squared, isn't it? So that's 2 squared minus root 3 squared under the square root. And you have your plus 2. Am I making sense? So that is 2 plus 2 minus 2 roots 4 minus 3. Is that not? Which is 4 minus 2 root 1. That is 4 minus 2, which is equal to 2. Can you see? So if a minus b squared is that, which means our a minus b, no need for brackets, our a minus b is what? Square root of 2. Can you see? And that means that what's our a minus b? Our a minus b is this minus this. Okay? So the square root of 2 plus root 3 minus the square root of 2 minus root 3 is actually root 2 in exact form. And that's the end. Okay? That's the end. So that's how to do questions like this. They are Olympiad, elementary stage of Olympiad program. That's where students are expected to answer this. But of course, Olympiad problems are not, they're not calculator exams. So you can imagine. And this is just the elementary stage, actually for junior category, not even for senior category. Interesting stuff. All right, so we're going to begin today's class. I'll send this to you later. So the last time under surds, we're able to look at multiplication, simplifying monomial surds. Okay, so today we will continue with surds again. It's Friday the 24th. We're still on surds. Before we begin, I'm sure you've seen the correction that I wrote for you. Okay, those of you that did it one way, I told you how to do it in another way. Okay, so today we'll be looking at how to multiply surds, addition and subtraction and multiplication. Let's do that. Okay, so the main objective for today is add, subtract, and multiply surds. That's what I want us to be able to achieve at the end of today. Like we said the last time, what kind of surds can we add together? Does anybody remember? Like surds. Thank you. Like surds. So let's say we have root 20 plus root 75. Do they look like they are like surds?
No, but you can simplify them.
We can simplify. Good. When looking at it at first, they look like they are not like surds, but we can simplify. So your root 20 will be root 4 times 5. Root 75 will be root 25 times, this is root 125, not 75. Okay, let's leave it as root 75. Then let's say minus root 125 minus root 27. Okay, let's extend it. So this is 25 times 3. That's 25 times 5. And that is 9 times 3. So that will be 2 root 5, 5 root 3, 5 root 5, 3 root 3. Then we collect the like terms. 2 root 5 minus 5 root 5 plus 5 root 3 minus 3 root 3. So that is negative 3 root 5 plus 2 root 3. So you can write this, or you can write the positive one first. So even though they look like they are not like surds, You can simplify and bring the like surds and simplify properly. Any problem, Miss Kelly?
No.
Okay, you're looking like you're confused.com. Okay. So this is not difficult. So we're not going to waste time giving you more example. All right. So I'm going to look at for multiplication. So it's just like the normal multiplication in algebra. Let's try to do this together. 2 root 3. What do we do first? Anyone? What do we do first? Talk to me, guys.
You
We change to 12.
You don't have to do that.
12.
you expand it first.
You can expand it first. If it was division, then you can maybe split the bigger one. But if it is multiplication, you can expand first. So if you expand first, do you agree this is 2 root 18? Why this is 2 root 36? Yes. Now root 18 can be simplified. But you don't need to simplify anything here. That's just 2 times 6. Justin, can you see why you don't need to change the 12?
Yes.
But if this question was maybe root 12 divided by root 3, then you can think about that. Because if you break it into 2, you can actually cancel. Okay? Instead of saying square root of 12 divided by 3, which also works. Okay? You can do this or this. But in division, in multiplication, you can multiply out, then simplify. Okay? All right. So 3 comes out of this. 2 times 3 root 2 plus 12. That is 9 root 2 plus 12. Okay.
Mr. Daniel,
Yes.
I think it's 2 times 3 root 2 instead of 3 times 3 root 2.
Yeah. So that would be 6, right? Am I right now? Thank you, Candy. Can I ask you guys to try this? So this is just like our normal algebra. You multiply this, then you multiply this, right? So it's just like normal algebra. So we are combining your previous knowledge of algebra with the properties of surds that you have learned. That's all we are doing, okay? As far as all these are concerned. So can I ask you to try this? Try it. Signify when you're done.
I'm done.
Okay.
I'm done.
Oh, great. So what do you get?
I'm done.
Final answer. Tell us the final answer.
I got negative root 6.
Negative.
Same.
Negative root 6.
Same.
Same.
Oh, okay. So there's no number. Okay, so the number cancel out, I guess.
Yes.
Ah,
Yes.
interesting. Is there anyone who didn't get it? Please signify now so we can do the correction and I can assign another one. Raise your hand if you didn't get it or you are still confused about something. Anyone?
Still doing it.
Still doing it? Okay.
I'm still doing it.
All right, great. So while they're still doing it, let's move to the next page and assign a different question. So if anybody has questions about the previous one, please speak up. That's 3, so this will be 4. Oh, I skipped a page. So 4. How about that?
Mr. Daniel,
Yes.
I'm done as well, and I got -√6.
Good. So if you get the -√6, you're good to go to the next one. If you did not get the -√6, please say something.
Mr. Daniel, I'm done with 4 and 5.
So I'm particularly interested in 5, the steps especially. You did do full expansion or you use something else?
I used the difference of 2 squares.
Good. That's exactly the reason I put that question. Okay, that's exactly the reason I put that question. Okay, just a sec. I will upload something for you now. Kelly's screen is always frozen. I wonder if she did that on purpose. Kelly, did you hear me?
No, I was looking at something on my phone.
Oh.
Because I use my phone for Zoom, so.
Oh, that's why the screen is frozen. I get it. Okay.
Mr. Daniel, I'm done with 4 and 5 as well.
Good. Okay. Also you, Justin. Good.
Yeah, I finished 5.
All right.
Thing.
Okay. Others, how is it going?
I'm doing 5.
4 and 5.
4 and 5. Okay. For those that finish already, I'm going to display something now. Please, I'll be taking if you have not finished 4 or 5, can you take the picture? Because I'm about to change my screen to something else. Can I change it?
Yes, I took a picture.
All right. So if you finish 4 and 5, can you use these 3 questions, A, D, G, on the left? Can you see the 3 questions on the left? So use them as the next 3 questions. So the last one is 5, so that will be 6, 7, 8. All right, take this as 6, 7, 8.
Do we have to WeChat you or just
No. Just solve it in your notebook.
okay?
Then we can discuss the solution.
Mr. Daniel, what questions are we supposed to do again?
It's on the screen. Those 3 on
Okay,
the
thank
left.
you.
Those 3
alright,
on the
thank you.
left. Mhm.
I finished.
No way. What is wrong with this girl?
I finished as well.
Oh my God. Who are these people? Bunch of aliens in my class. I need to tell the government we have aliens here.
I finished, Mr. Dan.
Okay, so Justin is also an alien. That's good to know. And Yanko, what was that?
I think that's Alex.
didn't say anything. That's Alex.
Oh, Alex.
Don't capture me.
I don't know why I mixed that up. I heard Alex's voice and I called Yanko. Yanko, please get out of my head. Okay. I'm trying to look for some interesting question because apparently these ones are too easy for you. Too easy, right?
No, these are actually really, really hard. This is way too hard. You should give us easier questions.
Right. Okay, so let's see what you did versus what should be done. Tell me if you can hear the audio. Do this. If you can hear the audio once I start. Did you hear the audio?
No.
Okay. All right. Got it. I know what's happening. Let's try again. Starting.
In this example, we continue studying operations with surds, this time looking at perfect square and difference of two squares expansions. In part A, we expand the perfect square just as we would for an algebraic expansion. We square the first term, add twice the product of the first and last terms, then add the square of the last term. We then simplify each term of the expansion. 2 times 5 times minus 1 is minus 10, so we have minus 10 root 2. The last term is the square root of 2 squared, which is just 2. We can then collect constant terms. In part B, look at the expressions in the brackets. You should see that they differ only by the sign of the second term. We can therefore write the expansion as the difference between two squares. We square the first term, then subtract the square of the second term. This works because if we were to perform the expansion using the FOIL rule, the middle terms would cancel. 2 root 5 all squared means 2 times root 5 times 2 times root 5. 2 times 2 is 4, and root 5 times root 5 is 5. We therefore have 49 minus 20, which is 29.
I hope that was the method you used. Those of you that did this. Yes? Good. Okay. Let's see. Can you see question I? 7I. Try question 7I, everybody.
Do we put 7i as 9?
Yes. You follow the same number.
I have finished.
No way. That's cube, bro.
Same.
Yes.
No calculator, right?
I don't think I can use a calculator on this and get the exact number.
Okay, good. Good. So I hope you can see that to multiply, to divide, to multiply, to add, subtract is quite easy. Let me see if I can give some stuff when it comes to addition. The addition questions that I can see here are too easy, so that's why I don't really care about them. So maybe I could go into division. We still have about 5 minutes. Let's go to division, even if I didn't plan that today. So this is easy, so there's no point wasting time on easy stuff, okay? So let's go to division. So when talking about division of two surds, or maybe division of a number by a surd. So by division, we mean maybe a root b divided by c root d, or some number k divided by m root n. So this is what we are interested in for monomial. And sometimes we can have binomial where you have maybe a plus root b, something like that. Okay, a plus root b. So this is what we are interested in here. But before we begin, we want to talk about this. Has anyone heard about this? These people call conjugate surds. Yes, anyone? Conjugate surds. You have actually heard about them because you just figured, you just did them. These guys, they are conjugate surds. Okay? They are surds with the same terms, but just opposite sign in between. Okay, so when we are dealing with the division of this form, we refer to conjugate surds. So let's write conjugate surds first. So two binomial surds m plus root n and m minus root n are conjugate surds. Okay. The products of any two conjugate surds is not a surd. Or should I say is rational number? It's a rational number. That's better. Is a rational number. Did you notice that when you did expansion of numbers like this, that you use difference of 2 square for, that you only got a number, not square root? Did you notice that?
Yes.
So when the surds are conjugate surds, you always get a number, no surd. Wait, did I erase this myself? So when you have monomial surds, how do you do division? So we take that first, then I will show you the binomial surd, which involve conjugate, and we'll practice more next time. So but for the activity that I'll be giving you on this, it will be in simple case of division, if any. Addition and subtraction and multiplication will be, it may just be addition, subtraction, and multiplication, and maybe 1 or 2 questions on division. But we'll do more of division next time and see in other ways in which we can apply them. Okay, so quickly now, to rationalize a surd, that's another thing that I forgot to mention. So when you say to rationalize a surd, okay, let's put it this way, example. So for the case of monomial, like this, or maybe like this, it doesn't matter. 2 divided by root 3. We are always trying not to have a square root here. Okay? We want to make sure the denominator is a real, is a rational number. So that is why we say we rationalize the surd. Okay? We rationalize the surd. So here, we ensure that denominator is rational. This is known as rationalizing the surd. Okay, for the sake of monomial denominator, you just multiply by the surd. Okay, for monomial denominator, we multiply both top number and bottom number. Okay, we multiply both the numerator and denominator by the surd, by the same surd at the denominator. I'm writing this in case anybody forgets. What does that mean? So in this question, we have 2 root 3, right? So we say times root 3 divided by root 3. Because this and this gives 1 anyway. So we have not changed the question. We have only multiplied by 1. Does that make sense? So this will be 2 root 3 divided by 3. This is the simplest form we can go. It's possible you have 4 root 3 divided by 5 root 2. Okay, so to do this question, 4 root 3 divided by 5 root 2, what do I multiply with? Anybody?
Root 2.
Just
Root
root
6.
2.
Just root 2. Where does root 6 come from? Who said root 6? Did I hear
Me,
somebody
I thought
say
we
root
have yes. I thought we have to like anyways.
Okay, so you just root 2 by the surd, all right? Just root 2. So this will be, what would that be now, Candy? 4 root 6 divided by 5 times 2, right? And that gives 4 root 6 divided by 10. Okay, so the idea is to make sure denominator, of course you can simplify, sorry, can actually simplify. I can simplify from here directly. So that's simply 2 root 6 divided by 5. That's what I should have written. That's the simplest form. Okay. So finally, just give me 2 more minutes and I'll wrap up the class. Since we've already started the division, let's just take one off. Finally, that would be 3. If you have 1 divided by root 2 plus 3, for example. No, 3 plus root 2 is better. So for this one, like I said, if you have binomial, you multiply by the conjugates. The conjugate is 3 minus root 2, 3 minus root 2. Can everybody see that? So this becomes, this is still times 1 doesn't change anything, right? But the bottom one, this is 3 plus root 2, 3 minus root 2. Times 1 remains 3 minus root 2. So this is the multiplication you have just done. Remember difference of 2 squares, don't waste time. So this becomes 3 minus root 2 divided by 9 minus 4. So that's 3 minus root 2 divided by...
Mr. Daniel, I think it's
Is it 2?
9 minus 2.
Why do I keep saying that? Thank you. That would be 7. Okay, this is the end of it. But sometimes, what if the question says if 1 over 3 plus root 2 equals p plus q root 2, find p and q. Look up, everyone. If this was the question that you have done, from this step, what would you do?
I will multiply 3 plus square root 2 on both sides.
On which side?
Both sides.
Both sides of what? Of this?
Yes.
I just said from this step. From this step, what would you do?
Oh.
Because
never mind.
everything we have done so far is correct. Even if this is the question, you don't need to multiply both sides by anything. You still follow the same step. So you have your 1, 3 plus
Oh.
root 2,
Okay.
and you have gone through different steps, and you finally got 3 minus root 2 divided by 7. You see, I'm not including this at the beginning. So don't write 1 on the left, 1 on the right, 1 on the left, 1 on the right, because a lot of you do that. Just focus on the left and simplify it until you get something that looks like the right. That's how you do things at this level. Can somebody advise what to do here now?
Change 7 to like 7 and power to -1 and then times into 3 minus.
No, you don't need to do that. Just split the fraction.
I think just separate it.
Just separate it. Like this. That's all you have to do. Write it clearly so you can see the coefficients properly. Because sometimes when you do this, what is P from here?
3 over 7.
3 over 7.
And what is Q?
Negative 1 over 7.
You see, Candy almost made the mistake of including root 2. This is why it's recommended to write this. Can you see that? No, root 2. The last one is root 2. Okay? So that's why it's recommended to write it in that form. So if you compare, you will see that P is the first one that stands alone, and that is this one. You will also notice that Q is the second one before the root 2, and that is this one. That's how we got the number. Any questions? Why is Mr. Iron Man smiling? It seems someone is sending you something funny, and that is taking your attention, which means you are not actually paying full attention to the math that I'm teaching you. So well done. Good job. Continue. You and whoever that is distracting you in my class. So in case you come across questions like this, you follow the same procedure from the beginning. You get to this point, you split it into 2, you pick out what you need. Okay? Questions? All right, I will send in the work that you need later. I believe everybody did this right. If anybody has questions, please speak up now or maybe later when we come back next week, Monday. All right? If there are no questions, this is where I say goodbye. I'll send you your work later online. Please do the Microsoft Word thing. Yeah, that reminds me, for the Microsoft Word submission, I would like to call your attention to something. Where is it? Where is it? Form 4. Okay, so sorry if I could quickly share this. Joey, I'll be opening yours. Joey, can I have more space next time? Can Joey hear me?
Yes, I can. What do you mean by more space?
More space in between the lines. Maybe skip one line.
Oh, okay.
Okay, the reason why that is important is this. Look at, is that Candy or Kelly? Kelly, you can actually send one picture. Can you see what Joey did? Just one picture. That's allowed. Just make sure there's space. Okay. So you don't have to, because this will take so much time and energy. You have to crop the first one, crop the second one, crop the third one. No, no need. All right. Okay, so that's that about that. Let's see. I think Shirley, I would also like to show her something. Miss Shirley, please note this. Can we avoid having question in vertical form? Because then you don't give me the opportunity to write things that I need to write. Look at this, for example. I think it was Melody or Sonia. Now look at this. Can everybody see this? I have space to write alternative workings.
Mr. Daniel, we
yes,
cannot see the file.
Oh no.
Yeah, we can't see.
Oh no, sorry. How about now?
Oh, yeah. Yeah.
Yeah.
So you were not seeing what I was showing Joey then? Oh my God. So I
Yeah.
have space. Can you see? I have enough space to show our other alternatives. Okay? So this format is very good. Okay? Oh, I didn't even look at this. Oh my God. Okay, but this is exactly what I was talking about. Okay? Quickly, this is what I was talking about with Joey. Okay? Space, so that if I need to do some correction or you don't have to miss it for me to be able to do correction. And this is for Kelly that I was talking about. So Kelly, one picture is enough. Or maybe you break them into two. Some people broke them into two. Maybe Yanko, I can't remember who. So please take note of this. Let's see Yanko's. You see, Yanko sent two different pictures. Okay, and there is enough space here. But of
No,
course,
we're not seeing that.
Okay, oh my God. Sorry, I forgot. Look at Yanko's. No, that's Shirley. Shirley, do you understand what I said here? This is Yanko. Can you see two different pictures? Okay, and I have enough space. But, you know, unlike what I have with Melody, I can actually write the corrections separately, side by side. But here, they are also too closed. So if the picture could, I don't know, leave enough space in between two work, or even the space beside here is enough for me to write any correction if I need to write any. So please take note. That's what I wanted to share with you when I give you another round of activity. All right. Well done, everybody. I'll see you next time.